Good morning, everyone. Thank you for joining us today for the Intro to HVAC Building Tune-Up and Commissioning webinar. My name is Beth, and I'll be hosting today's webinar. We'd like to start with a safety moment this morning. Safety is a core value at PGE, and we would like to remind you to be safe around electricity. As you consider installing or retrofitting new equipment, please keep safety in mind. We would also like to encourage your family and staff to be prepared with an outage kit, and you can visit our website for more safety information. And the website address is portlandgeneral.com/safety. We also want to thank the Energy Trust of Oregon and the Northwest Energy Efficiency Alliance for their support in co-sponsoring this series of free energy efficiency trainings that are open to all Northwest utilities and their customers. Before I introduce this morning's presenter, I'd like to show you some tools you'll be using during the webinar. To the right of your screen, you'll see the chat window, and a polling window will appear at the end of the session. If you have any questions during the webinar, you can submit them to me, the host, through chat, and the instructor will answer them at the end of the webinar. At the top left corner of your screen, underneath the Quick Start menu, you'll see several tools, which you can see here now on your screen, and I will highlight them, including an arrow tool, a text tool, and a marker tool. The presenter will ask you to use these tools on specific slides during the webinar. And now I'd like to introduce this morning's presenter, Greg Nelson, Professional Engineer and Certified Energy Manager. Greg is a mechanical engineer with more than 16 years experience in commercial and industrial systems design and operation. He focuses on finding energy-saving opportunities within businesses, and Greg specializes in identifying energy efficiency improvement opportunities with businesses, schools, governments, and other nonprofit organizations. And now I'd like to hand over the presentation to Greg. Greg?
Thank you, Beth, and I too would like to thank you all for attending. What I want to do is start off by asking you a quick question, and this is going to be one of the opportunities for you to use those tools that Beth had mentioned. And I think for most of the questions that I will ask you, you can use the marker tool, but feel free to use the pointer or whatever. But take a moment and indicate what best describes you. What's your role? So far we've got HVAC technician and consultant, maintenance manager, okay. So we've got a wide variety of people attending here, and this being a introductory webinar, what I want to do is hit on some of the high points. Some of you, if you're a consultant specializing in energy management, or if you're an energy manager with a lot of experience, you may find some of this information a repeat of past experience. But I want to try to address, the introductory topics, and if you want to get into more depth, I encourage you to attend our commissioning seminar. Thank you very much for the participation. So today's agenda, we will go over a background, basically the background of tune-up and commissioning. Then we'll go into benchmarking. And if any of you attended last week's webinar on energy monitoring, we touched on benchmarking, but today I'm going to go into a little bit more detail and talk about some of the tools that are available to help you benchmark your facility. Then from there, we'll go into basic tune-ups, and then we'll close out the webinar with questions and answers. So starting off with terminology, I want to hit these quickly so that we have some common terms that we will see later on in the presentation, and we have an understanding of those terms. First of all, kilowatt. It's a measurement of power, electric power. And to put it in real basic terms, if you have a building and the only thing that's turned on in the building is a 100-watt light bulb, then your power consumption would be 100 watts. If you have 10 of those light bulbs on, it'd be 10 times 100, or 1,000 watts, which is equal to 1 kilowatt. Now let's say those 10 light bulbs were on for an hour. you would then consume 1 kilowatt hour of energy, because kilowatt hours is a measurement of energy, kW, or kilowatts, is a measurement of power, and so power times the amount of time that power is being consumed gives you an energy. And in electrical terms, we measure that in kilowatt hours of consumption. Moving on down the list, we've got therms. This is a common measurement that you would see on a natural gas bill. And then finally, BTUs. But I guess I should step back. Therms would be a measurement of natural gas consumption, and specifically energy consumption. Some natural gas bills will have a therm per hour or a peak demand, which would be similar to a kW type measurement. And so, especially if you've got if you're a larger consumer of natural gas, you may need to look at that on your bill as well. Moving down to the bottom, we've got a British thermal unit. This is a common term that's used when we try to look at the total consumption of energy within a building or a facility. A British thermal unit is a relatively small energy measurement. It's basically equivalent to the amount of heat given off by a lit match. And so often when we talk about building energy consumption, we're going to be referencing thousands of BTUs per hour. I'm sorry, thousands of BTUs rather than BTUs, often referred to as kBTUs. So moving from the terms into, why are we here? Why are we talking about this topic? If you have a new building, why would you want to tune it up, or why would you want to commission it? Well, let's talk first about how a new building comes to be. You have a building owner who will typically work with an architect. I'm going to switch colors here real quick to make it a little bit clearer. So the building owner tells the architect, I need to house 100 office employees, and then maybe I want a little cafeteria in the bottom floor, or maybe I want a retail space in the bottom floor to kind of have a mixed-use facility. So the building owner works with the architect to come up with the intent for the building. The architect will then start putting pencil to paper, or as the case may be nowadays, CAD drawings together, and building the skeleton and schematic of the building. They will also then typically consult with an engineer to design the HVAC systems. Another engineer may be designing plumbing, and another engineer is doing structural. So lots of components need to go into this design of the building. And then once the design is done, the building owner and or the architect will work with the contractor to put that design into real life, basically start constructing the building. And during construction, the contractor may have interactions with the engineer. Typically, these are pretty informal interactions. Maybe submittals are being sent from the contractor to the engineer saying, hey, I want to put in this type of fan rather than the one that was designed. Does it meet your design intent and things of that nature? And so once the building is built, then the building owner will have to work with a building operator. And for smaller buildings and less complex buildings, the building operator may be an employee that has many other roles. But for larger structures, we would typically have a building operator that is whose sole focus is, maintaining the temperature requirements and the building at for its intent. And so there's many lines of communication in this process, and anytime you have a line of communication, you have an opportunity for misinterpretation of intent. And so even if everyone has the best intent in mind, things are going to be overlooked, and a tune-up and or commissioning of a new building could help you reduce your energy consumption and manage your energy usage better. So why would we tune up an older building? It's been built, it's been operating just fine over the years. Why bother? Well, particularly for larger buildings, maybe we've got a new tenant coming in, and we've got to redesign a space that was maybe once designed as an office, and now it needs to be a laboratory. So in that type of instance or in similar instances, the building owner may work with a contractor, and it may be the same contractor that built the building, or it could be a brand new contractor that's not familiar with the original design intent of the building. And that contractor will work with an engineer or a series of engineers to do the structural, electrical, HVAC, plumbing as needed. And then we still have the interaction between the building owner and the building operator. This building operator may be the same one that's been involved since the opening of the building, or it could be a new operator. And so again, we've got lines of communication, lines of interpretation that may or may not be interpreted as intended. So here's another opportunity for you to help me guide the rest of the presentation. Can you take a moment and describe the type of facility you are most interested in talking about today? And if you got more than one, feel free to mark more than one. My intent here is to help shape this and possibly future presentations and make this better for everyone. So Donald, or Don, I'm sorry, it looks like you may be interested in office and manufacturing. So again, much like the first informal survey that we had, we've got a wide variety of interests here, and so I'll try to touch on a wide variety of introductory topics. Thank you very much. So here's a typical office energy consumption profile. Whenever you're looking at tuning up or commissioning a building or a facility, you want to get a sense for where the energy is being consumed so you can concentrate on areas that may give you the best bang for your buck. You don't want to invest a ton of time in an office building typically on water heating, for example. But you do want to take a look at space heating, ventilation, space cooling. That's often referred to as HVAC, heating, ventilation, and air conditioning. But you also want to look at lighting, typically in an office space. And depending on your usage, maybe computers are another thing you want to look at. And if you are in a office manufacturing environment, maybe there's some other big energy consumers that you're aware of, or you should think about being more aware of that you could concentrate your time on as well. I should point out that this pie chart is, tuned to the Pacific Northwest. So we've got, a relatively mild summer. We've had a great summer so far, but other summers are cooler, and, even the mornings and evening times can be relatively cool. And so our cooling loads aren't as high in the Northwest as our heating loads tend to be. That being said, a lot of office space, the conditioning of the air is influenced by other factors like lighting, like computers. If you've got a lot of computers, or you've got some old lighting that's inefficient putting heat into the space, your heat load may be different than this pie chart depicts. Moving on to hospital. And a hospital would be similar to a lab space typically. So here's an example where we still have some of the same usual suspects to look at. HVAC tends to be a large chunk of the energy consumption. We still have lighting as a big consumer, but now we do want to maybe look at water heating. And then, other equipment in a hospital or lab space could be, special testing equipment and things of that nature. And finally, I want to touch on industrial. And this pie chart, may not be the most useful, but it does illustrate one point. Is typically in industrial environments, we want to focus on other things rather than our ventilation, rather than our water heating. And refrigeration is tricky. If you are an industrial customer who has refrigerated warehouse space, you may want to concentrate on refrigeration. But others of you may want to focus more effort on process cooling, compressed air, dust collection systems. And most of these technologies have, PGE has seminars that can help you hone in on some of these larger industrial consumers out there and look for opportunities for improvement there too. So now that we know roughly where energy is being consumed in some typical environments, I want to move on to benchmarking. The first step in benchmarking is nailing down how much energy is consumed in your building or facility. And one way to do that is to document your monthly utility bills. This would be your electricity bill, your natural gas bill, maybe you've got a propane bill. And while you're at it, maybe you want to document your water consumption and some other non-energy consumers. So here's an example of a customer who has documented their monthly energy consumption, and one thing they can see over the years is their energy consumption has gone up. And so simply by documenting your consumption, you can start to ask yourself questions. Maybe this customer has been expanding. In this case, it's a private school, so maybe they've added classroom space. Maybe they've added portables. So maybe it makes sense that their energy consumption has gone up. And if they're managing their energy consumption, maybe it's gone up less than it could have if they hadn't been paying attention to it. So documenting your energy consumption is not going to necessarily point you to answers, but it can help you ask some questions to help you determine what level of tune-up or commissioning you want to look into for your situation. But who has time for this, right? I mean, not all of us have the time. Like I mentioned before, maybe you're an energy manager who also has to maintain facilities equipment and, maintain the happiness of tenants in an office space. So sometimes there can be some conflicting priorities. If you're getting complaints about temperature in an office space, you may need to tune your system in a certain way that would actually consume more energy. And the key is just to be aware of what changes you are making and what are some future opportunities to consider moving forward. So if you don't have time to document your monthly energy consumption, here's a quick alternative. You'll find this type of graph on either your gas bill, your electricity bill, and even your water bill sometimes will have this. And so what this shows is 13 months of energy consumption. At a quick glance, we can draw a line where we see the average energy consumption. In this case, this customer is consuming 8,100 kilowatt hours per day. And then we can do some quick math. So down here, I've done the math, 8,100 times 365. So just under 3 million kilowatt hours of energy consumption at this facility. And then, as we've shown here, there's a less than a 5-minute task. And so you can maybe spend another 5 minutes on your natural gas bill and get a feeling for what your total annual energy consumption is likely to be at your site. And it's a quick alternative. So how do we use that? Now we're talking more and more about benchmarking here. If you're in an office space, you probably want to compare yourself to other office spaces, right? Or if you're a lab space or a manufacturing facility, you want to compare yourself to your peers. And one opportunity for commercial customers in particular is to refer to a report that has been put together by Northwest Energy Efficiency Alliance, one of our co-sponsors of this webinar. Periodically, they'll submit this report. The latest version of this report came out in 2009, and I believe there's going to be a new revised report coming out at the end of this year, or at least scheduled to. And what this report does is it looks at buildings, particularly commercial buildings in the Pacific Northwest, and in the Northwest in general, and looks at occupancy types, where they're located, what's the floor area, and what type of building systems they have. Basically, what type of heating and cooling systems they have, and hours of operation of those systems. Another resource that you could look to if you want some additional information is the Energy Information Administration. And this website has an abundance, almost an overabundance of information for you. And again, they look at occupancy type, in this case, census region, floor area, occupancy level, age of facility, and the list goes on. There's a lot of factors that they look into, and if you really like looking at data and crunching numbers, this is the site for you to focus or help you focus your energy management opportunities. But I want to point out where we are. You know, here in Oregon, we're in the west, and specifically by census region, we're in the Pacific. And so the energy data that we can get from EIA will typically pertain to Washington, Oregon, California, Alaska, and Hawaii. So we're talking about very diverse climates. And the cooling loads, obviously, in California are going to be different than the cooling loads in Alaska. So we have to take this data and tweak it to make sure it reflects what's going on in our neck of the woods. So I've taken a little time to tweak the data for you. So this chart here is a combination of data that you would find from NEA and from EIA. They don't all, both those documents don't cover all these occupancies, but together they give you a good picture for a lot of commercial activity in our region. So here we've got principal activity and total kBTU per square foot per year. So here's that kBTU number that I referred to before, thousands of BTU per square foot per year. And so let's look at an office space. We would expect the average typical office space to consume about 83.4 kBTU per square foot per year. If you're a newer facility that's gone through LEED and maybe has worked through the Energy Star process to hone your energy consumption and reduce it as much as possible, we would expect this number to be quite a bit less. But again, we're talking about the average office space in our area. So kBTU is useful for energy managers, but it's not so much useful for people who don't have the time to devote or a lot of time to devote to energy management. So to help with that effort, I've converted this kBTU number to a kWh and a therm for two different scenarios. In this case, we've got a office building that has basically all electric service. So they've got electric heat, electric water heating, no natural gas in the facility. So we would expect that type of office space to consume about 24.4 kilowatt hours per square foot per year. Now, if you've got an office space that has gas for heating and gas for water heating, we would expect the electric energy consumption to drop and the therm's energy consumption to come into play. So in that scenario, we would expect 16 kilowatt hours per square foot per year and 0.29 therms per square foot per year. And so that kind of gives you a sense for the magnitude of therms. Therms are a bigger amount of energy than kilowatt hours. And you know, you can dig deeper to get the exact conversion, but that's just a quick indication. So how can we use this information? So let's say we're an office building, and I know by doing my quick graph check that I'm consuming about 120,000 kilowatt hours per square foot per year, and I know I'm just over 6,000 square feet. So I do some quick math, and I come up with 19.3. That's 19.3 kilowatt hours per square foot per year. Now I'm going to ask you, is this good or bad? And one of the ways that you can indicate this is to just kind of circle good or bad, or if you feel bold, you can use the text tool and enter some text. But I'll just give you a moment to chime in. So we got a few bads out there, and we got a good. That's good. I typically like to see a variety of oh, and there's a question mark too. So my answer to this question is it depends, and that's an answer I like to give as an engineer. It does depend. You know, what are your goals? Are your goals to be a leader in energy efficiency, a role model for others? Then maybe you need to bring that number down. Are you an office building that has a lot of computer activity, either a big or even a small data center can make your kWh per square foot per year go up pretty quickly. But yeah, even a computer closet or a server closet can have drastically larger energy consumption and cooling requirements than a typical office space does. So depending on what's in your building, maybe you've got a retail space in the bottom floor of your office building, or you have a restaurant. You know, all these things can throw these numbers off. So that's a quick way to benchmark your facility and maybe can help point you in a direction. One of the big major uses I see for this is to help you determine, you know, do I need to spend a little bit of time on tune-up, or do I need to bring in an expert to help me commission my building? And we'll go into details as to the difference between commissioning and tune-up in a bit. So if you didn't get the answer that you wanted from that quick benchmarking, there are other tools out there. Or if you know that you do want to dive a little bit deeper into benchmarking, you can skip that a lot of that benchmarking that I discussed earlier. You still need to track down your annual energy consumption, but Energy Star gives you some tools to help hone in on different aspects of your building. For example, like I said, if you are an office building but you have a decent amount of computer space, either a data center or big server room, you can factor that in. You can give information as to how many computers you have and how many square feet of data center you have and things of that nature. And so Energy Star is a good site to go to if you want to dig deeper and benchmark a little stronger, give you a better indication of where you stand in relation to your peers. So Energy Star facility types, you know, these are the similar commercial occupancies that we've talked about already. They have slightly different names, but you can see some common occupancy types. And so let's say you're one of these types and you do want to do some benchmarking. You go to energystar.gov. You can click on Buildings and Plants. And then you want to either use Portfolio Manager or Target Finder. Portfolio Manager is for those of you who know you need to dig deeper and get a good high-quality benchmark of your facility. Target Finder is going to be in between Portfolio Manager and that quick technique that I talked about earlier as far as how much time it takes to develop the benchmark. Regardless of which one you choose, I want to give you a feeling for the type of information you need to input into the model. So here's some sample inputs for, in this case, a refrigerated warehouse facility. Like we talked about before, no building is like every other building out there. In this case, this refrigerated warehouse also has some unrefrigerated space, and it also has some office space. So let's start with the office space. We enter the square footage, the hours of operation, the workers on the main shift, the number of computers, and then how much of the space is heated and cooled. We also then go in and enter the similar type of information for the unrefrigerated warehouse and then the refrigerated warehouse. And so after all this information is put in, and keep in mind, yeah, this is more information that needs to be gathered. It's going to take more time than the quick approach that I talked about earlier. But in this case, this facility is 160,000 square feet total. And while this looks like we need to input energy consumption in kBTU, we actually have an opportunity to do some drop down and check boxes. And so basically we can input our energy consumption in common terms, kWh for energy and therms for natural gas. So don't get scared if you're not familiar enough with the kBTU concept. There are many opportunities for you to use common terms and common inputs in this input for Target Finder. And Portfolio Manager is going to be very similar as far as the types of input. It's just going to dig even deeper, you know, into the hours of the second shift and other shift operation and things of that nature. It's going to have you put in monthly energy consumption so that you can track your benchmark over time. And this Target Finder is more of a one-time, quick, or relatively quick benchmarking opportunity. So here's the results from that theoretical customer. We see that our building, and it's the design, it's how our building is currently operating. It's scored a 70, which basically means that our building is doing better than 70% of the similar buildings out there across the nation when you adjust for weather and other factors like that. We can tell Target Finder what we want to hit. So in this case, we said, well, we want to be better than 80% of the buildings out there. It also gives you a feeling for what the average is, and as you would expect, the average building is better than 50% of the buildings out there. So there's some other information on here, but I want to move on. I don't want to belabor this too much. So that's a tool to help you hone in on your benchmarking. If you're an industrial customer, you may not be able to use the Energy Star tools, the Target Finder and Portfolio Manager, but there are other pieces of information out there that could be useful to you. The EPA, which is the company that runs the Energy Star website, has information on compressed air motors, process heating, pumping, and steam. And like I mentioned earlier, PGE has some presentations, some seminars, some webinars on industrial equipment operation and ways to save energy with that operation of that equipment. So I think this is going to be the final survey I have for you. Can you describe your building and check everything that applies here? And surprise, 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 we've got a diverse group out there. And what I'm going to go into is some common things that you can try as an operator, some simple things you can do to tune up your building operation. And before I do that, I want to talk about the levels of commissioning. So on the scale, if you were to put commissioning on a scale, at the front end, we've got basic tune-ups. And then as you move up the scale in complexity, you've got full-blown commissioning. So basic tune-ups are things that typically could be performed by the customer. And if you are a facility operator who has some time, you may want to consider some of these basic tune-ups that we'll discuss. If you don't have the time, maybe you need to bring in a contractor to help you do these tune-ups, and they can be worthwhile, especially if you've benchmarked your facility and know you've got some drastic improvement that needs to be made. If you've got a long way to go towards your goals in reducing your energy consumption, you may want to consider full-blown commissioning. And in this case, a specialist is typically required. And because of that, maybe you want to do some research to make sure that it's going to be a cost-effective option for you. If you are working with a 10,000 square foot office space, you probably don't want to go into the full-blown commissioning. But like I said earlier, maybe you need some assistance from a contractor to help you do some, what I would say is involved tune-ups, you know, something above a basic tune-up that you could typically do. Maybe you need to get your contractor in to do some cleaning of condenser coils, and I'll go into that here in a little bit. And that's not the only thing that you could do. Maybe you want to have a consultant come in and look at your lighting opportunities and things of that nature. So here we are with lighting. Here are some basic tune-ups that you should consider for your lighting systems. And like I mentioned before, you know, lighting not only affects your lighting energy consumption, but it puts heat into your space, and therefore it can affect your HVAC consumption as well. So what we want to do is we want to reduce lighting energy consumption while maintaining an adequate light level within the space. And one way you can do that is to install occupancy sensors or tune the occupancy sensors that you have. Many of us may have these occupancy sensors that automatically turn off lights when a room is not occupied. But I don't know how many of you have had the opportunity to look into how these work and how these can be tuned to meet your needs better. You can change the direction where the sensor is looking. I don't know how many conference rooms I've walked into where the lights don't come on when you walk into the room, but they sure come on and off based on activity in the hallway outside. So you may want to re-aim or aim this sensor to a better location. You can also change the timing of this. Do you want to wait 10 minutes after no activity to turn off the lights, or do you want to turn off the lights sooner than that? Moving on, we've got time clocks. Now, this device here may look like something from the Stone Age to some of you, but it can still be a very useful tool. We see these often in buildings where they want to control their outdoor lighting. So they'll put these tabs in here on a time clock that rotates in a 24-hour period, basically. And so one thing you want to look at is what's the positioning of these tabs, and then over time, these can work themselves loose, and they end up dropping to the bottom here, or getting lost, or even users change the settings and may not change them to an optimal setting. A lot of times with outdoor lighting, we probably want to look at that at least on. We probably want to look at it every 3 months just to make sure that we're reacting to the changing hours of daylight right now, right? Right now, the days are getting shorter, unfortunately, and the nights are getting longer. So we want to start maybe increasing the number of hours that our lights are operating. But we definitely in the springtime, we want to start decreasing the number of hours that our outdoor lighting is operating. So take a look at those. Maybe you've got a more detailed control system, an electronic one. And so those might also incorporate some sweep controls. Sweep controls is where you can automatically turn off lights at a certain time. If you know that your building occupants go home at 5, maybe you want to sweep the lights off at 6, turn off all the lights in the facility. You can even give a warning by flashing the lights before they get shut off. And this allows any occupants that are in the room or in the facility to turn on their own lights whenever they want to. And if you do have sweep controls, another key thing is to make sure if you have the program ability to do it, sweep them off multiple times. That way you can capture any time that someone overrides the system. For example, if somebody stays at work till 7, the first sweep went off and shut off all the lights, but then the person working goes in and turns on their own lights that they need. If you sweep the lights off again at 8 and 10 and midnight, you have a better opportunity to drastically reduce your energy consumption. Zoning is another key thing. You want to make sure that your light switches are controlling lights in the area that they're in. I've been in some facilities that have gone through a retrofit, for example, and now a light switch on the east side of the building controls lights in the warehouse on the west side. I mean, that's an extreme case, but if you don't have a light switch located properly, the occupants aren't going to take the opportunity to turn off the lights when they should. Moving on to maintenance of lighting systems. You want to make sure you clean the fixtures. You can measure light levels to make sure that lighting is adequate. Many times, especially if you've got an older facility, maybe the lighting has been retrofitted, but maybe they did a one-for-one replacement. And many times when that is done, you end up with more light than you really need. And so by measuring light levels, you can tune your lighting. Maybe you can delamp some fixtures. Maybe you can completely eliminate some fixtures, which is going to save you not only energy, but maintenance costs as well, right? You don't have to replace those bulbs. Replace T12s and older T8 fixtures. Basically, if your lighting systems are 10 years old, you should really consider doing a retrofit. And you can have your favorite vendor come in and propose a retrofit. They'll typically be able to give you a price for that retrofit and also help you do the paperwork through the Energy Trust of Oregon to qualify for incentives. And the key with most incentives for commercial buildings anyway, for that matter, is to pre-qualify yourself. Many of the incentives require some form of pre-qualification. So if you haven't gone through the process before, talk to someone who has, talk to your vendor. If you're not getting answers that you need, feel free to give us a call, and we'll give you some numbers that you can call here later. Replace HID fixtures, replace old ballasts, group relamping. These are all things that are we can get you more detail on in our lighting seminars and webinars. So moving on to HVAC tune-ups. These tune-ups are going to be geared towards facilities that have this type of equipment. What this is often referred to as a packaged rooftop unit. And in this case, we've got a gas line going into it, so we know that it's got natural gas heat. But a lot of these tune-ups can also apply to heat pumps, which would have electric heat in them, basically. So much like the lighting tune-up, we want to implement a maintenance plan. And part of our maintenance for HVAC is to look at our thermostats. You know, where do we have the temperatures set where we want them? Is the time programmed correctly? Things of that nature. You know, and this isn't something that you can do once and then forget about it, because building occupants tend to make adjustments to these thermostats, even if they're behind a locked box, or if there's a code that you have to enter. You know, people are resourceful. They'll find ways to adjust things and maybe not have the systems operating at performance levels that you would prefer. Change filters per manufacturer's recommendations. This isn't going to be a huge energy saver for you typically, but it will potentially prolong the life of the equipment. And so as you're looking at maintaining your equipment, you also want to consider how long you want to keep the equipment active and workable for you. And then clean equipment per manufacturer's recommendations. Here's a picture of a condensing unit. This is a unit that basically gets the heat out of the building in your HVAC system if you have a split system. If you've got a rooftop mounted system, this condensing function is built into the one unit. That's why it's called a packaged rooftop unit typically. But split systems in particular, these condensers are located in typically inconvenient areas. They're kind of hidden typically. Maybe they're behind a bush, maybe they're below a tree, and so they can get dirty, and we want to clean these so that they can dissipate the heat effectively. And if you've got a heat pump, then this is also your source of heat in the wintertime. A heat pump is an AC unit that's going to work basically in reverse. It's going to pull heat from the outdoors. Even if it's cold outside, it can still pull and concentrate heat and put it into the space. So cleaning this is going to give you a double benefit. It's going to improve your cooling performance and it'll improve your heating performance if you've got a heat pump. Here are some other resources that you can consider to look into. These documents are on commissioning, but even if you're, mainly looking at tuning up your building, there are some tidbits in here that you can find useful. A lot of these documents are getting a little long in the tooth, but they still have some great information in there. And so I mentioned earlier the Energy Trust of Oregon as an opportunity for, for example, lighting incentives. Money from the trust can help you implement energy efficiency projects at your facility. But it's not just limited to lighting. It can be HVAC. If you've got industrial applications, there are a lot of incentive opportunities there. And you may already know where energy is being consumed in your facility, and you may already have been participating in Energy Trust programs. But regardless of that, if you want to ask any questions, you can go to the Energy Trust website, or you can contact the people here on this page. If you're a commercial customer, you can contact Paula Conway, and her information is here. If you're an industrial customer, you can contact John Maloney. The key that I mentioned earlier is, get your questions answered early. Make sure that you pre-qualify your project if that's required. Smaller lighting projects, insulation replacements, small HVAC equipment replacements may not require a pre-approval, but definitely your more complex, larger retrofits will require pre-approval. And so these people can help you discern your next best steps. So with that, I want to turn it over to Beth so that we can get into our question and answer session.
Thank you, Greg. And I'd like to remind you all of some of our upcoming webinars and seminars listed here on the screen, and you can visit our website to find out more information at energyeducationcenter.com. Greg specifically mentioned some lighting seminars. We have an LED indoor and LED outdoor seminar on September the 25th, which is actually not listed on this, but that might be something that you would be interested in attending. Before we proceed to the question and answer portion of the webinar, I'd like to remind everyone that you can continue to submit questions to me through chat, and I will ask them of Greg. Within a few days, we'll send you a follow-up email with the recording of this session and the PDF of the materials. And I'd like to draw everyone's attention now to a polling survey, which I've just opened in the bottom right-hand corner of the screen. If you could take a couple of minutes to fill out the survey, we do value your feedback and use it to improve future webinars. And now I'd like to proceed to the question and answer portion of the webinar. Greg, our first question is energy consultation also available for compressed air systems?
Yes, the quick answer is yes. The long answer will follow here. There are many avenues for energy consultation on compressed air systems. One would be to talk to John Maloney, because compressed air is typically in the industrial environments. And he can talk to you about your situation, where you're located. He can make sure that he gets you in contact with the right people to talk to. Another resource is, your vendor, whoever's maintaining your compressed air system. They will often be willing to look at your system and help you tune it. They may be focusing more on capital improvements, but they can often give you some good advice on how to, improve the performance of your system. And definitely compressed air, especially larger compressed air projects, are the type of projects that need to be pre-approved before you purchase equipment.
Thank you, Greg. And our next question is, can you suggest some resources for a novice non-engineer to identify inefficient HVAC systems for large commercial buildings?
I would recommend a number of resources. First of all, do the benchmarking that we mentioned, whatever level that you want to look at. I would also encourage you to attend the commissioning seminar that goes into more detail, the PGE seminar that's co-sponsored by the Energy Trust and NEA. That will go into more complex HVAC systems, chilled water systems, and give you some tools to examine your system. But basically, one of the key things in an HVAC system, especially if you're just getting started in trying to track down energy improvement opportunities, is economizers. Economizers are a tool. They're basically a series of dampers and sensors in your HVAC system that allow you to use outside air to cool your space rather than using the compressors and multiple fans to mechanically cool your space. And I've seen some studies out there that indicate that 75%, maybe that's aggressive, maybe 50% of the economizers out there are not functioning properly. And when you've got a non-functioning economizer, you may be consuming up to twice as much cooling energy than you need to, especially in the Pacific Northwest, where we've got an annual average temperature of about 55 degrees. 55 degrees is typically the temperature that you need to provide to your space. So on average, we can use outside air for cooling most of the year, And even when it's slightly warmer than 55 degrees outside, we can at least use that outside air to decrease the load on our mechanical systems. So those are some quick things. Hopefully that helps.
Thanks, Greg. And then the next question is regarding a strategic energy management workshop that we're having on September the 19th. A participant asked if we could talk more about that, so I'll answer that question. Greg, we do have a seminar, a workshop on September the 19th in Hillsborough that is hosted by the City of Hillsborough and the Partners for Sustainable Washington County Community and the Hillsborough Chamber. And it is called Strategic Energy Management, an Overview and Training Plan. And the purpose of that seminar, workshop, is to understand more what strategic energy management is and some of the continuous improvement models, the Plan, Do, Check, Act model, and to develop a training plan for you and your company or other attendees to understand, to develop the skills to understand how to approach that model. And the participant can chat with me offline if that did not answer the question. And then I think we have time for one more question, and that is, Greg, when it's time to replace equipment, how do I find the best, most efficient option for my use?
That's a good question that will take more than 10 minutes to answer fully, but let me give you some high points. The thing you want to look for is, what's the efficiency performance of that equipment. If you're looking at the HVAC system, typically the efficiency is going to be rated in either SEER or IEER. Without going into huge detail into what these numbers entail, basically we want a bigger number, and bigger is better. Energy Star has some tools that you can plug in, different options. If you have a HVAC system that has a 12 SEER rating, you can compare it to one that has a 19 SEER rating, and those just kind of give you a feeling for the high and low end. But you can also see some cooling equipment that has a SEER into the 24s. So bigger is better on SEER. If we're talking about water heaters, we want to look at basically the fuel efficiency, and again, bigger is better. Typically, we're talking about a percentage, and so a condensing water heater is going to get you into the 90% efficient range, which means 90% of the gas that's being burned is generating heat that's going into the water. The rest is going up the flue. And you got to take those numbers with a grain of salt. Both the SEER and the combustion efficiency in those systems can be affected with how you operate the system. If you're, for example, cycling a furnace on and off, it may have a fuel efficiency of somewhere in the 90s, but if you are constantly stopping and starting it, you're going to waste more heat up the flue. You're going to heat up and cool down your ductwork, which puts less heat into the space where you want it. And so much like commissioning and tune-up, you can't just put in great equipment. You need to put in the good equipment and then follow the instructions, program your thermostats correctly. Like I said, this is a long answer, and it can get even longer. Let me think if I can touch on anything else. Water heaters are typically going to have a combustion efficiency. If you've got a heat pump water heater, it's going to have more of a EER type number where you want that to be as high as possible. Another opportunity is if you are buying equipment that's Energy Star rated, it will typically have a sheet on it that kind of puts that equipment on a scale with its peers. If you've got a water heater, it'll show you where on the continuum of water heaters that water heater should be operating. I know in one of my in an old house that I was in, I had a furnace that was put in the late 90s, and the furnace was at the bottom end. It had that Energy Star tag on it, and it was on the bottom end of performance. I ultimately didn't choose to change that out because it wasn't cost effective to put in a better piece of equipment. But I then made sure I redoubled my efforts on programming my thermostat so that I can make the best management of my energy consumption.
Thanks, Greg. That's a lot of good information. The next question we have, and I do see we have a little bit more time for questions, so I apologize about cutting the questions off earlier. You can continue to submit them. How do I know if I need, you mentioned lighting, how do I know if I need a retrofit for my lighting or getting all new fixtures? How is one or the other better in the long run?
It all comes down to cost, right? And I've seen some retrofits that come in way less than a complete replacement and vice versa. So the advice to you is, work with a contractor that you're comfortable with. If you need to get multiple bids, that's not a bad thing. And just ask your contractors about what they are able to provide you. Not every contractor is going to be able to support a retrofit, but they may be better suited to provide you with a replacement. Bottom line is, older equipment, especially lighting that's 10 years old or so, can benefit from either retrofit or replacement. And it also comes down to timing, right? If you're operating 24/7, you may find some benefit in retrofitting equipment rather than taking it out of service and leaving some areas dark while you're doing some work in them. So it all comes down to what's best for you, and any improvement in energy efficiency can help you reduce your energy costs.
Thanks, Greg. And I think we have, this will be the last question. I've heard that it takes more energy to heat up a building than it does to keep it at a constant temperature 24/7. Why should I program my thermostat to raise or lower the temperature when my building is unoccupied?
In commercial environments, there isn't a whole lot of information out there, answering this question, but I look at it this way. We can refer to the plethora of information that's out there on residential systems. So if you go to the Energy Star website, they will say, if you're leaving your home for more than 4 hours, or if you're, sleeping for more than 4 hours, set back your thermostat. And what that gets at is kind of some of the nuances of, does it truly take more energy to reheat my space or not? And the way I like to look at it is, if you are maintaining your house at 70 degrees 24/7 in the middle of winter, outside it may be 20 degrees. So there's a 50-degree difference in temperatures. And that difference in temperature is what's going to be driving your heat loss in your house or in your commercial facility, for that matter. And so if you're able to reduce the thermostat down to 60 degrees, depending on how long you are operating in that reduced condition, you may not get all the way down to 60 degrees before you turn your system back on. But what I will guarantee you is whatever heat you've lost during that time, it's going to decrease as your temperature decreases. If we get down to 60 degrees within the space, there's now only a 40-degree difference between indoor and outdoor temperature, right, in my example. And so that's going to mean less heat is leaving your space during that time period. And there's other nuances. I've got to reheat not only my air temperature but my space temperature. I got to increase the temperature of the desks and other thermal masses in my space. But the bottom line is that heat would have left, at least that much heat would have left when you're running 24/7. And probably more heat is going to leave your building when you're running 24/7 at one temperature.
Thanks, Greg. And that was our last question. I'd like to thank all of you for joining us today and thank the presenter. And we hope to see you at a future webinar and seminar. We'll stay online just a little bit longer in case any of you have any questions. But thank you very much for your time.